So, I feel like, I know in geometry you definitely have seen trig ratios before. In Algebra 2 you guys do trigonometry and stuff too, right? Yes? Yes? I think so. I think you guys did. But if not, if nothing else, you did do it in geometry. I do know that. You did hit trig ratios and stuff like that. So trigonometry, right, is the study of right triangles. And so sine, cosine, tangent, secant, cosecant, and cotangent, those are all ratios that we can use and apply in right triangles. There are specific cases where we can use those things in non-right triangles, but for the most part, the biggest, where they kind of originate from are those right triangles. Okay, so that's where we get them from, and so we'll be using them for a little bit here and a little bit to solve for sides of right triangles. So trigonometry is a study of right triangles. All right, so I don't know if I want to use green here. So we've got our trig ratios, right? So reintroduce these to you. Sine, okay, of an angle x. We have cosine of x, right? And then tangent of x. And then, of course, we have cosecant, secant, and then cotangent. Okay. Our 6 trig ratios here. All right. They're going to be using those. Remember things, like sine, for example, and cosecant. I wrote those across from each other specifically because sine of x, right, is equal to 1 over the cosecant of x, right? The reciprocal of cosecant is sine. And I think that's like one of the dumbest things in math that for some reason when, they're coming up with these trig functions, they decided that sine's reciprocal should be cosecant. It's like, why not just say that sine's reciprocal is secant and cosine's reciprocal is cosecant? But that makes no sense to me. But that's the way it is, okay? And really, I don't understand. Yeah, so that's the way it is. Same thing with cosine then, right? So I gave that one away. Cosine of x is 1 over secant, again, for reasons that I don't know and have not been able to find out, okay? And then tangent's reciprocal is cotangent, and that's the one where it's like, okay, this makes sense. Some basic stuff right there, right? And so we know we have these trig ratios, right? And there's something, what do? They relate angles with sides of a right triangle. So let's get a triangle here so we can actually do some relating angles with sides. Okay, so let's draw a right triangle here, and I'll draw like the classic 3, 4, 5 right triangle, right? A nice Pythagorean triple here. And I'll call the vertices A, B, and C. All right. And so when we take the sine of something, we're always taking the sine of an angle. Okay. Remember that sine, right? Sine of angle A relates the side opposite of angle A. So opposite to angle A is 4 over the hypotenuse of that right triangle. So sine of angle A is the opposite leg over the hypotenuse of the right triangle. Okay. Opposite leg over the hypotenuse, which is, in this case, 4 over 5. Okay. And then cosine of angle A, right, it relates the adjacent leg over the hypotenuse. Okay. I'm very careful here to write adjacent leg. Okay, that word adjacent, right, is less clear of a meaning for us than opposite, right? Like we're taught about opposites since we're like 2 years old or maybe younger than that. But then the word adjacent, your parents don't really say. It's not like okay, which what's opposite from hot? And you're like cold, and then your parents are like, okay, what's adjacent from hot? You don't learn that, right? Because that's doesn't even make any sense. But the word adjacent, right, just means next to. So angle A, 3 is next to angle A, right? It's like one of the adjacent sides there. Now we have this Widmar, 5 is also adjacent to angle A. And he's like, yeah, you're right. But that's why we say adjacent leg. 3 is the leg, 5 is the hypotenuse. Okay, so 3 is the adjacent leg. So 3 over 5 there. And then tangent, okay, the other ratio here, right? We've got it's the opposite leg over the adjacent leg. So 4 over 3. Okay. So the sine of an angle is equal to the ratio of specific sides. Cosine of angle A is equal to the ratio of 3 over 5, and the tangent of A is equal to the opposite leg ratio over the adjacent leg, which is 4/3. Okay, and then so because we know what we know with the other trig functions here, okay, then if sine of A is 4 over 5, cosecant of A, well, that's the reciprocal. So instead of opposite leg over hypotenuse, it'll be hypotenuse, right, over opposite leg. It's just the reciprocal of sine, so it's going to be 5/4. Right? Secant of A, it will be the reciprocal of cosine, so it's going to be hypotenuse, over the adjacent leg, which in this case then is 5/3. And then cotangent is the reciprocal of tangent, so instead of opposite over adjacent leg, it's going to be adjacent leg over opposite leg, which is then 3 over 4. Okay. So of course, to remember all this, right, we have that lovely mnemonic device. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Okay, so katoa. My geometry teacher in high school told me that was Native American for he who runs with geometry book. I thought it was funny, but that's okay. You don't have to laugh. Okay. Sounds more like something you would chant around a campfire as you're like walking around it or something like that. You know, some sort of like pagan chant or something. All right. And then of course it has, you know, we've got something for cosecant. I don't know if you know. So cosecant, secant, and cotangent, right? Well, that's choshakao. Okay, choshakao. So you can also, you know, remember that one, or just remember the ratios too. But it does say something, choshakao. So there you go. Sokatoa choshakao. It's a funny word. Okay, but really that's, you know, what we're going to go with. All right, so let's see here. I'm going to come up with a... And let's see here. So I'll make a right angle. I'm going to call this angle here. Now, a common variable used in trigonometry is this Greek letter. Whoop, you can't see it. There it is. Okay, Greek letter theta. Okay, it's T-H-E-T-A. Theta. Theta. Okay, I don't know if I can pronounce it well. T-H-E-T-A. Theta. How you pronounce it? Okay, theta. Theta, right? And then some other Greek letters like to show up at this point too. It's like this little fishy looking thing. Okay, anyone know what that Greek letter is? Alpha. That's right, alpha. Okay, the start of the Greek alphabet. I think it's a lowercase alpha because the uppercase alpha literally looks like our letter A, capital letter A. That's lowercase alpha. Okay, and let me put some sides in here. So let's say like 1 and 2. Okay. So in this case, right, haha, I've made it harder because there's a missing third side of our right triangle. But how can we find this missing third side of our right triangle? What can we use? Ooh, silence. This has been talking too long. Now we're all asleep. Okay. How can we solve for a third side of a right triangle? Yep, Spencer. Pythagorean theorem. That's right. Okay, Pythagorean theorem. So leg squared plus leg squared equals hypotenuse squared. And so Spencer, what goes where then in this case? Very good. Okay, yeah. The only thing we have to really watch out for there is that the 2 must go in for the C. The 1 can go in for A or B there. And so you get a squared plus 1 equals 4. We subtract 1 from both sides. You get a squared equals 3. Square root both sides. And we're going to say a equals the square root of 3. technically, right, we're in an equation setting. We're taking the square root of both sides. We should say plus or minus root 3. But why don't I put the plus or minus here? Okay. Right, in context, right, a negative square root of 3 doesn't make sense for the side there. So there we go. There's our missing side. Okay, so I want you guys then go ahead and find sine of theta, cosine of theta, tangent of theta, and then of course they're reciprocal trig functions, so cosecant of theta, secant of theta, and cotangent of theta. Let's go ahead and do that real quick. And don't worry about rationalizing, okay? Don't worry about rationalizing. Don't worry about rationalizing. Alright, so Cece, what'd you get for sine of theta? 1 over 2, okay, opposite 1 over opposite leg 1 over hypotenuse 2, good. How about for cosine theta, Cece? Yep, so adjacent leg, square root of 3 over hypotenuse 2, okay, good. And then what about tangent, Cece? 1 over the square root of 3, right. Okay. So there's that. Good. Thank you, Cece. And let's go to then Nick Miller. So cosecant of theta there, Nick. What'd you get? 2 over 1, right? Okay. And then how about secant? 2 over the root 3. Good. And then cotangent. Root 3 over 1. Okay. Very good. So there are those. Any questions on that? Or just setting those up here. Not really using them beyond that right now. Just setting up the ratios. Familiarizing ourselves, refamiliarizing ourselves. Okay, good. Of course, right? We can have like, let's see, I'm gonna do something like this. We also can evaluate trig functions. We're gonna only focus on evaluating trig functions using our calculators for today. Okay, so we're gonna focus on evaluating trig functions, but only with our calculators today. So, for example, if we have like sine of 135 degrees, okay, we just literally go to our calculators right now, if we want to. Okay, we're going to use our calculators for now, and we can, like, you know, type in sine of 135, okay, all right, and we get, whoops, sorry, it's frozen. 0.0883686861, right? You get that? Is that what everyone got? 135 degrees, 0.088368. You all got that? Like 2 people typed in the names, they're like, yeah, it's probably right. It's wrong! No, that's not it, okay? Because if you press the mode button on your calculator, my calculator is set in radians. So we have to arrow over, hit enter for degree. And now we type it in. 0.707, right? Now, that's familiar, right? No, not really. Okay, but anyway, so it's about 0.707. Okay. So, long story short, please make sure your calculator is set in the correct mode. All right. You can do things like cosine of negative 30 degrees. Okay, so literally, again, I can go to my calculator, cosine button, negative 30, hit enter, boom, 0.866, approximately. And then let's say I want to do like cotangent of 195 degrees. Alright, so I go and I press the cotangent button, but there's no cotangent button. Oh, but wait, Mr. Widmeyer, I see above tangent, there's tangent to the negative 1. And we know that when we see negative 1, that means 1 over tangent, right? Well, no, it's not, okay? Second tangent, that button is not 1 over tangent. Yes, I know it says tangent negative 1, but that's really tangent inverse there, okay? So don't press second tangent to use cotangent, okay? The reason why there's no cotangent button, okay, or command, is because the calculator is like, you can type in 1 over tangent of 195, okay? And it gives us that. If you do second tangent of 195, it's not the same thing, right? Tangent negative 1 like that, the second command there, that's something separate. That's tangent inverse. Okay, I know it's confusing because it's, to the negative 1 power, you put 1 over that. I get it. It's kind of a, poor, thing with mathematics, I guess. There's a notation thing. But it's really 1 over tangent of 195, which is then the 3.732, we'll say. Okay, so please make sure you type things in correctly. All right, so you guys go ahead real quick, take 2 seconds, and find the secant of 110 degrees. Okay, take 2 seconds, find the secant of 110 degrees. Okay, just make sure you got it. Take 2 seconds, find the secant of 110 degrees. Secant of 110 degrees. Alright, secant of 110 degrees. Alright, should be done. Negative 2.924. Okay, negative 2.924 there. Okay. And then, of course, we don't want to only work in degrees. We can also, for example, find the sine of pi over 3. Okay. How do I know that this is in radians? Because there's a pi there? Maybe, right? Okay. More importantly, there's no degree symbol. So that's how we can assume that we are in radians here. Okay. All these other angle measures had degrees with them, so we assume, we don't assume, we know there are degrees. Here, yes, it's got a pi. If there's no degree with it, that's what gives it away that it's radians there. So sine of pi over 3, make sure you change the mode in your calculator before you do it, 0.866. Okay, 0.866. And again, you can do it for the other ones too. But just make sure you're changing the modes back and forth, okay? Whenever you're evaluating those trig functions, change your modes back and forth there. Okay? Oh, okay. Gotcha. Okay. You're not going to use the book?
The book has, if you look at 6.1 and 6.2, it has, 4 problems between them.
For point slope?
Yeah.
Yeah, the point slope section, I think it's 6.3, isn't it? 6.2, okay.
Yeah.
Gotcha.
So,
all right. Neat. All right, thank you. I'll use this. Yes, thank you. Okay. One more thing here, and then we'll be done. All right. And I just want to be able to use these trig ratios. So how do we use these trig functions, right? All we're doing is just setting them up. How can we actually use them? What are they good for, right? So, well, they're good for solving for sides. So we'll solve for the missing sides. Okay. 4 there. Okay. And we'll just do like, I'll do 1 and then I'll have you guys try 2 on your own here. Okay. So here's our right triangle, right? We want to solve for missing sides. Now, can we use, or is Pythagorean theorem going to be helpful in this problem? Why not? Yeah, we are missing 2 sides, right? Pythagorean theorem is only really useful when we have 2 sides of the right triangle and we're going to find that third missing side. Here we're missing 2 sides. So we need to use some other method, right, to solve this right triangle. We need something maybe that can relate angles with sides. Well, we just talked about sine, cosine, tangent, secant, cosecant, cotangent, right? Or cosecant, secant, cotangent. That relate angles and sides of a right triangle. So it's we have some choice here, right? We can choose to relate the 30 degree with the 2 given sides, or we can choose to relate the 60 degree with the 2 given sides. We never really used the 90 degree angle, and I don't have a good reason for that, except for that it just doesn't really work. So, but anyway, the 30 or the 60, use one of the 2 acute ones there. And so, I don't know, let's just use the 30, okay? So the 30 degree angle, we want to solve for this side, which is opposite, right? And then we have the hypotenuse. So we want to use the trig ratio that has opposite and hypotenuse in it, so that would be sine. So sine of 30 degrees, we're going to actually put the angle measure in here. Before, right, we didn't have the angle measure, we just used the letter for the angle. But now we have the actual angle measure, we can put it in there. Sine of 30 degrees equals opposite x over hypotenuse 4. Okay. And then we just solve for x, so we multiply both sides by 4. We get x is exactly equal to 4 times the sine of 30 degrees. Alright, don't do any weird stuff here. Don't try multiplying that 4 and the 30, right? It's not sine times 30, it's sine of 30. It's a function acting on 30. That 30 is inside something, so the 4 can't touch it. Okay, the 4 can't touch it. So we just type this into our calculator. Okay, and I do see weird things. Again, make sure you're in the correct mode. What mode should we be in right now? Degree mode, right? Because we're dealing with degrees and our angles here. And so 4 times sine of 30 degrees is 2. Kind of nice, unexpected, right? To get some nice numbers in there. Alternatively here, right, we could have used a 60 degree angle. If we had chosen to use the 60 degree angle, which trig ratio would we have used? Cosine, right? Because now this side is not opposite, it's adjacent. The side is, the leg here now is adjacent, so it's the adjacent leg and the hypotenuse. So we could have also said cosine of 60 degrees equals x over 4, and then solve from that. You get the same answer, it'd be 2. Alright, let me have you guys solve here then for these. Alright, so just 2 more. The first one can take you an instant to do, and the second one might take some more time. Okay, so go ahead and solve for those missing sides there. I'll give you like a minute or 2. And again, 3 decimal places, please, if you're around. 3 decimal places, unless the direction is otherwise specified. 3 decimal places. Right. So, Becca, do you have an answer for us for the first one? 10. Okay. X equals 10. How'd you solve that, or how'd you set it up, or? Okay. Tangent of 45 degrees equals x, opposite leg, over 10, adjacent leg, and then you just multiply it by 10, which is then, not approximately, sorry, exactly equal to 10. Did anyone get that using a different reasoning? Yes?
Since the one angle is 45 and that one's 90, the other one must be 45, so that means the two sides will be the same.
Isosceles triangle, exactly right. So we can still, yeah, no, I mean, that's exactly right. Yeah, the two sides will be the same, right? Okay, so that's a geometry property you can use there. So either way you want to go about solving those is fine with me. You don't have to, you don't have to use trig if you can solve without the trig. Good. Okay. So Ellie, are you more of a geometry person? Would you consider yourself?
I don't know.
Not really.
I
don't know. Some people I find, there are some students that like really aren't that big of a fan of algebra, but then they get to geometry, like, yeah, geometry, and then it's like they're flip. People that were like loved algebra but hate geometry and stuff. So anyway, I just was curious. That's all. All right, and then how about Jonathan for the next one here? What'd you get for this one?
I got 8.2.
Okay, so how did you set it up? How did you set it up? What trig ratio did you use here? Cosine. So you said cosine of 23 degrees equals, careful, it's adjacent leg over the hypotenuse. What side's the hypotenuse here? X. So it's going to be 9 over x. Okay. Again, very easy to think about that. Adjacent, it just means we think it just means next. Be careful, it's adjacent leg. So that's the setup. So we'll multiply the x over here. We get x times cosine 23 degrees equals 9. And so then x equals 9 over the cosine of 23 exactly. Or approximately it'll be like 9.777. Questions on any of that? Very good. Okay. So then let me give you all your assignment.